Let's look at some shell methods. So for a shell method, we are dealing with volumes on the shell method. So for shell method, we have something like this shell method. A shell, it's something like a cylinder form like, so it's like we have something like something like this. In a rectangular form, so there is a length, there is a breadth, and there is a height. So we have something like this for a shell method. So it's V equals to length times breadth times height. So when you have a sheet like this, you have to fold it. We fold it to a cylinder, we'll have something like this. When you fold it to be a cylinder, it will be like this. And then before we fold it, so if this outside part, what we call it, if we have a circle like this, the outer part, we call it a circumference. So what is the equation of a circumference? Circumference is 2 pi r. So a circumference is like the length is 2 pi r. So the breadth is the thickness, and the breadth is the thickness, and the height. So when you convert this one to equation, well, say 2 pi x is represented as r, or it can be y, it can be x, dependent, represented as radius. So the thickness is this change in x, the difference between this strip, this one can be stripped, I think. So the height, it's y, is the equation, can be in equations. So we have something like this. So when you convert it to those equation of the strip, we are doing the shell method. So we have something x, y, and change in x, change in x. This is a strip. So when you talk about a shell method is the rotation different from the strip. Unlike the disk method, is in the same strip, the same rotational axis. So if you have a strip, the strip, you get it when you draw the equation. They tell you have a strip. When you are dealing with volume, you'll have a strip. So the rotation and the strip must be different for a shell method. So we have something like v or y dx. So this must be different to have a shell shell. Yeah, this is a shell. The other way is like this. The strip must be in different axis with the rotation if it's a shell method. Like here we'll have something like this. This is a shell method. The rotation and the strip is not in the same, so it's a shell method. So if you have a shell strip can become, so your limits, see here. So a limit you get when you draw the graph, you'll see how the limits can be your x-axis, your y-axis, depend on in the direction of, or the nature of the equation. So for two graphs, so if you have two graphs like this, and then they said use a shell method, so you see your strip, obviously it's in the x-axis, so it touches the x-axis, the smaller part touches it, like it's in the, it's parallel to the x-axis like this. Strip, so the rotational it will be like this. So this is what, this is a shell, because the rotation and the strip are not in the same x-axis. It's rotated in the y-axis, the strip is in the it's in the x-axis, the strip. So how do you know which one is which graph is which graph is which graph is which? Like here we are given two graphs. So because we are given two graphs, we have something like this. How do you know which one is? So from your strip you draw a dotted line. So what is the number here? There can be 1, here can be 2, so this means it's a graph number 2, graph 1. So you put as it is. This one, the graph number 2 is the biggest one, is this one. The smaller graph, it's this one. So this is how you find your graph, and you must check what they are saying. It rotated about the x-axis or y-axis, so let's check this one as well. So you can see, as you can see, you stripped it here, and the smallest part it's in the y-axis, so it's in the, so if they say it rotated about there, for it to become a shell, it must rotate it in the x-axis. This must rotate this direction, because it will be in the rotated in the x-axis, so it will be a shell method. It rotated it in the x-axis, and you stripped it in the y-axis, so it's a shell. So how do you find the value of which one it's graph 1, which one is graph 2? So you draw a dotted line like this. So this one is 1, this one is 2. So the graph that touches here, it's a y2, and the smaller graph is this side. So the difference between the shell method and the disk method is that the disk method rotates in the same axis with the strip. It's in the same axis. That's the difference between the disk method and the shell method. And the disk method rotated in the same axis with the strip. So like if it's like this, where is the strip? The strip is the smallest part. Is this is the strip. So where does it touch? It's if you have something like this is stripped. The strip is the smallest part. It's the smallest part. It's the smaller part of this rectangular block. It's stripped. So the strip touches at the x-axis. So that means for it to be a disk, must rotate in the same axis. This is a disk method. You see, it's a small part. So the strip you get it when you draw a graph. So you always have a strip when you draw a graph. And what is it missing? What is it missing? What was it? And what? Okay, so a shell. Let's go to a shell. A shell is different from this one, so it differs. So if we rotate it in the y-axis, the strip is in the x-axis. So we have something like this. If it rotated in the axis, the strip must be in the y-axis. So a shell method, it's like this. The strip is the one that touches the x-axis. So that means for it to be shell, it must rotate it like this direction. Rotate it way in the y-axis. So this is how you find those two, the difference between the two. So I will add more on this topic. We'll do the exercises. Keep on watching. We'll get deeper and deeper. This was just an introduction. Okay, that's it.